Hello, welcome back. In the last video, we discussed finding limits at a vertical asymptote. So now we're going to take a look at some special ones, some special trig functions. For trig functions, again, we tend to deal with vertical asymptotes. And for these, it's really just easier to graph them, or at least just in your head memorize what they look like. So our first step is just really to define where the functions have a domain restrictions. The domain restrictions for your trig functions, these are your vertical asymptotes, your VAs for short. That's going to give you a vertical asymptote always. So for the first one, let's take a look here. Tangent of x. Tangent of x can't be pi over 2s. So for example here, this would be like pi over 2. We would have an asymptote. Here, negative 3 pi over 2. There's our other asymptote. Now, if you notice, they all carry kind of the same shape. So I can say, well, what would be the limit as we approach 3 pi over 2 from the right side? And I can find that. Well, here's, sorry, let's just do pi over 2. We'll just keep it simple. Pi over 2 from the right side. Well, here's pi over 2. As I'm approaching on the right side of the graph, notice we are going down the asymptote. So this is going to approach, in this case, negative infinity. Don't forget the function there. Cotangent, cotangent the the pi's and the zeros. So for example, here's 0. This would be pi. Here is negative pi. What happens if you eat too much pi? You get negative pi right there. And those are our asymptote. This is what cotangent looks like. Cotangent is a lot like tangent, but it's just kind of flipped. So what if I wanted to find the limit as x approaches negative pi from the left of cotangent of x? Well, here's negative pi, the left side again, is going down that asymptote. So again, this would be negative infinity. And I can just look at the graphs of those. So you do have to know what these look like in order to be as successful as you can be. So for secant, you can't be the pi over 2, so secant kind of follows tangent. Remember, so secant follows tangent. It's 1 over cosine. And the reason it's pi over 2, we can remember, secant is 1 over cosine of theta. And you just don't want that cosine of theta to be 0. Well, where's cosine 0? Pi over 2, 3 pi over 2, negative pi over 2. And that's how we get those. So here we got negative pi over 2. Here we got pi over 2. This then would be over here, negative 3 pi over 2. And way over here, positive 3 pi over 2. And of course, I can use those to get my limits as well. Cosecant, remember, is just 1 over sine of x. Well, where's sine of x equals 0? Well, that's your zeros and your pi's. So here we have x equals 0. Here's negative pi. Here's pi, and so on and so forth. So let's take a look at how we can use these graphs to get our limits. So for the first example here, we say, what's the limit as x approaches pi from the left? So I'm going to approach pi from the left of cotangent. So here's cotangent, here's pi. On the left, we are going down the asymptote. So we're going down. So this is going to become for us negative infinity. Secant, pi over 2. So for this next example, now we want to go from the right of pi over 2 for secant of x. So for secant, here's pi over 2. On the right side, remember that's the right side. There we go. Let me write that out better, a little better for you. This is our right side. And notice it goes down the asymptote, so it's going to go negative infinity again. I like those negative infinities today. I don't know why. And that's how we do trig functions. Very simple, very easy to do. All right, so tomorrow we're going to take a look at what happens at a horizontal asymptote. And I promise you, that's the easiest things you'll ever do all year long. I look forward to seeing you then. Bye-bye.